Hi folks, and welcome to this video, which is part 1 of our Furby project. So as we told you in the previous video, we are going to make our own Furby based on this 2005 Furby, but it's going to be about twice the size, because all the scaling is going to be based around this eye mechanism.
This eye mechanism being designed and made available by another maker.
So this is the name of the maker and his YouTube channel. So it's Will Cogley Nilheim Mechatronics. And it says Nilheim Mechatronics is all about fusing mechanics, electronics and a little artistic creativity to make top-notch robotics and animatronics.
Okay, so Will's made available several eye mechanisms, and we're using the simplest eye mechanism, which can be 3D printed. And he also provides some electronic schematics to connect all the circuitry up, and some code on the Arduino to get you started. So yeah, we're using the simplest of the eye mechanisms, and we're going to try and incorporate it in the Furby, and also we're going to try and develop the code a bit further.
And we'll put a link in the description to his YouTube channel.
It's a good blend of somebody who's got electronics and programming skills with artistic creativity.
So it takes 6 servos altogether, because it's got lids both above the eye and below the eye. So haven't you got a servo for each lid, Paul?
That's right, yeah, there's a servo controlling each lid, so 4 lids will equal 4 servos.
And then the other 2 servos are for controlling the eyes themselves. So the eyes move in 2 axes, don't they, both?
Yeah, just
that way.
Left and right, and then it'll be up and down.
Up and down.
Behind the eyelids.
So Paul's painted these eyeballs, but these aren't the actual eyes that we're going to use. You've just done these quite quickly, just to give us an idea, haven't you?
That's right, because we'll want to fasten together the servo mechanism, which is quite a detailed construction, putting all the screws in and getting it working. And then once it's all fastened together, we'll want to operate it and see how it works.
So we're not sure yet how we're going to make the eyes. We're thinking about maybe trying airbrushing to get a nice iris on it, but not sure yet, are we?
No.
So the screws that Paul needed arrived, so he's been able to assemble it up to this point. And you changed one aspect of it, didn't you, Paul? You changed to carbon fibre rod.
Yeah, just on the bits that support the eyelids. I found that the screws, they were a little bit too long, and they were sort of going through and scratching the eyeballs. So I changed to carbon fibre rod because I could adjust the length perfectly, and also I found it made a slightly better bearing surface. And you can sort of glue it in with super glue. It takes super glue very well, so I thought it was better to change over to that for these particular points here. Yeah.
This is the carbon fibre rod, isn't it, Paul?
Yeah, it's great stuff. It's pretty cheap. It comes in different diameters. This is 3mm, different lengths, and it's really good hobby material. It's very, very strong and very light, very easy to cut too, and it super glues terrifically well to 3D printing plastics like PLA.
So that's it there, isn't it?
This is it here. This particular piece is stuck in, and it provides a nice pivot.
So how many servos have you got assembled so far, Paul?
Loosely assembled, we've got all 6 in, but as I'm putting it together, I'm finding that sometimes it's quite tight for space for putting things together. It's a really good design, and there's not much space at all, so you've got to do it in a certain order, and sometimes I put the servos in before I shouldn't, so I've got to take them out again. But at the moment, all 6 servos are actually in place, but not completely fastened down.
So what's the next step with this, Paul? What are you next working on?
The next step is to cut some more little bits of carbon fibre for the pivots, the eyelid pivots on this particular eyeball, and then finish putting the rest of the screws in.
And we've had 2 more components arrive, haven't we?
Yeah, this circuit board is like an expansion board. It connects to the Arduino's I2C port. So it allows the Arduino to control up to 16 servos with just a couple of wires.
But we're just using 6.
Yeah, we'll just be using 6 of these servo connector ports here.
It wasn't very expensive, this either, was it?
No, like a lot of modules that are made for the Arduino, because the Arduino is so popular, the modules are made in a great number and by different people as well, mainly in China. So you can pick up something like this, a ready-made printed circuit board, and I think I paid £5 on eBay.
And this is the other component that has arrived.
Yes, it's a 2-axis joystick, sort of left and right and up and down, and also if you press it, it's got a switch on it as well. Now initially the eyeballs will be under the control of a program on the Arduino, and the user input for controlling the eyeballs will be this joystick, so we'll be able to move them left and right and up and down. I say initially because ultimately we'll be writing a different program when everything's installed in the Furby that we're making, and that will be down to us how we have the eyes moved then. Obviously we won't want to move them by a joystick, we'll want that under some sort of automatic program control.
Yes, because we're going to video the 2006 Furby we've got. We're going to video some of the eye movements it has.
I guess when you say eye movements, you really mean eyelid movements, don't you? Because the eyes in the 2005, 2006 Furbies don't actually move about, do they?
They're the same as the eyes that you're constructing here. Both the eyes move.
Oh, is that right?
And the lids.
Oh, great. Yeah, so as you say, we'll be videoing the original Furby. We'll be seeing if we can replicate those with our little Arduino sketch that we'll be writing when it's installed in the Furby.
Plus, we'll be able to get some different movements because these move independently, whereas the eyes on the 2006 Furby just move in unison.
Yeah, so I think you said to me we'll be able to make it wink, for instance, because we can control one set of eyelids independently from the other.
Well, I thought also if it's waking up, it could just open one eye.
Yeah, that's a good idea.
Funny.
Yeah, that's a good idea. Yeah.
So, Paul, you've put the carbon fibre rod in this side now and assembled this part of the mechanism, and you've put all the screws in.
Yeah, it's essentially fixed together now, the servo eye mechanism. All the screws are in, and that bit we can say is done.
You made another adjustment as well, didn't you? You used some sort of Teflon tubing here.
Where the servo arms connect to the linkages to move the particular part of the mechanism, it's difficult to take all the slack out, so I used Teflon tube through the hole and then a machine screw going through it, and that allowed me to tighten the machine screw up enough to compress the Teflon tube enough to take all the slack out of the hole, so you got a nice snug fit. And of course Teflon is famous for being non-stick. It's very low friction, dry surface, it doesn't need lubricant, so that's good as well.
And you're working on this now?
Yes, so all the necessary components we just put on a piece of wood to keep them all together. So you've got Arduino servo driver board, 2-axis joystick, and this here, which is just a wheel controlling a potentiometer which will control the movement of the eyelids. And there'll be one last thing to put on here, which is a push button switch, and once all those things are on that piece of wood we can wire them together and then hook the servos up, power it up, and we should be good to go.
So this potentiometer with the wheel, this is the first time you've mentioned this in this video.
I believe this controls how far the eyelids go up and down, and then there'll be a switch here which will actually trigger the eyelids to move to whatever this position's been set at. I think that's how it works.
And you're just 3D printing a box at the moment for the switch, aren't you?
Yeah, just a little box to put the switch in here, and then all those things can be wired up then.
So you've got the switch affixed to the board now with your little 3D printed box.
Yeah, that'll operate the eyelids.
And you've been doing some wiring. You've got some wires coming off the potentiometer here.
To control how far the eyelids close, yeah.
And those are wrapped underneath this Arduino and are connected to this joystick here.
Yeah.
You were telling me this joystick here on this board, there's two potentiometers there.
Yeah, you can actually see them on the side. They're slightly smaller than this style of potentiometer, but it's still
Do the same thing.
exactly the same thing, yeah.
So there's one here and the other one is there. So what's the next bit of wiring you've got to do, Paul?
So I'm just connecting these potentiometers and this switch across the...
Right, so the switch isn't wired up yet.
No. So I'll be connecting the switch up next. Probably waiting for the jumper leads to come through the post so that we can connect everything up to the Arduino, because you've got to plug into these little sockets here.
Right.
And then connecting the servos onto these pins here.
So, Paul, the jumper leads have come and you've now connected the whole lot up, haven't you?
Yeah, it all went together quite quickly in the end, the wiring. So we connected the I2C servo driver board to the Arduino with the jumper leads. Did the rest of the wiring on the Arduino. Connected up the trim pot for the eyelids and the XY joystick for the eyes and the button to operate the eyelids. Connected all the servos up in the right order, powered it up, and yes, it worked. It just needs a little bit of trimming on some of the values to make things like the eyelids operate in total synchronization.
So you put a program on the Arduino that was provided by the maker of this?
Yes, the maker provided a program, and that's what we're using initially to make sure that the eye mechanism's all right. And I'll obviously have a play around with that program, trim the values to get everything working in synchronization, and then together hopefully we'll try and choreograph some eye movements based on Furbies.
Well, after we've had a demonstration of these eyes with you using the joysticks, the next thing we'll do is power up one of the old Furbies, 2005 or 2006, and film one of the eye movements to try and replicate. So Paul's going to move the eyes manually now with the joystick. Wow. You know, just seeing them move there, it's given me ideas already.
How's that?
Yeah. When I first thought about this Furby project, I was thinking maybe a touch sensor on the head for petting.
Oh, yeah.
And a touch sensor on the belly for giggling.
Mm-hmm.
But now I'm thinking of using touch sensors so that the eyes will look where you're touching the Furby.
That's an interesting idea, yeah. Yeah, there are a lot of possibilities, aren't there?
So you're using a power supply at the moment?
Yeah, the power supply is providing the power to the I2C servo board just for the servos, and the I2C servo board is actually, the electronics on there is being powered off the Arduino, but it's the power supply that's providing the power to the servos. So I suppose in a Furby model we would have a separate power supply for the servos.
Separate power supply to what? One for the servos and one for what?
One for the servos, providing all the power to the servos, and another power supply powering up the Arduino and the I2C board and any other electronics to keep the sort of heavy-duty power to the servos, which could have a lot of noise on it, separate from the power that powers up the electronics.
Oh, that's interesting. Well, there'll certainly be plenty of room in the body for two battery packs.
Yeah. It's the advantage of doing a big Furby model, isn't it?
And there's one last thing you've got to do before we power up the Furby, the 2005-6 Furby, to have a look at eye movements. And that's, you said it's something called trim.
The values inside the program, that's set where the servos should be, according to the position of the potentiometer, need trimming so that the servos operate in unison. You can see as I'm opening and closing the eyelids here, they're not all closed there when they should be, and when I move the potentiometer, the bottom ones are moving before the top ones.
Right.
So there are various ways you can get these to respond in the program by altering the values.
Okay, so that'll be the next thing you work on.
It will, yes.
Okay, Paul, so now you've been working on the eye mechanism and you've been trimming those values so that the eyes don't try to move further than they can. So the servo doesn't try to force the eyes further than they can move.
That's right. So we've adjusted the range so that it doesn't exceed the range of the mechanism on the vertical eye movement.
And you've also done that trimming so that the eyes can close properly.
Yeah, the eyelids weren't in synchronization, and I thought initially that it might have to have some values adjusted in the program, but I saw that I hadn't adjusted the servos correctly on the left hand side. As you look at it, the servo arms were in a different position when it was at rest, so I made a mechanical adjustment there, and all seems well now.
Okay, so can you give us a quick demo? Let's see it blinking. Ah, yes, they shut perfectly now, don't they?
Yeah.
Oh, they're moving a lot nicer, aren't they?
They are, yeah.
Much smoother, aren't they?
They are.
So we tried to power up some of the Furbies this morning to see if we could get some footage of them to try and replicate. And unfortunately we found that 4 of the Furbies out of my 5 Furbies, all the eyes have gone at once.
They're all in very poor condition, aren't they?
And the eyes won't move. And the one Furby where the eyes do still move is the Furby that I got with the broken speaker. So what I did instead was I looked at some old footage that I have on my channel of my 2006 Furby, and I looked at the movement of the eyes when I asked the Furby, "How are you?" And this is what it looks like. So what the Furby is answering there is, "I am very happy."
Yeah.
So I broke it down into the 4 words to see what movement you were getting, and I found that the eyes only move on the first 2 words and not the last 2.
It's interesting, isn't it, when you actually look at the Furby's eye movements closely, how little it's doing.
Yeah. I think there's a tendency to sort of move things too much when you're someone that doesn't understand how to animate things, like ourselves.
Like ourselves, yeah. I guess we've got a lot to learn because animation's
about
art.
subtle. Yeah, it's an art and
subtlety,
about subtlety.
And bringing things together. The eye mechanism that we're using, of course,
it's far greater range.
It's far greater range in all the dimensions, but we probably won't want to use that when we are duplicating original Furby eye movements.
And also I found that I'd remembered incorrectly. I thought that Furbies, the eyeballs moved both left and right and up and down, but they don't. They only move left to right.
So Furbies only have this eye movement, and they don't have this eye movement. Now, I think we'll want to duplicate a lot of original Furby eye movements at first, won't we?
Yeah, oh yeah, because you learn from that how to do animation. Because straight away I can see you don't want too much.
Don't want too much, yeah. But maybe in the future, when we've got a few original Furby eye movements down,
we can do something different.
We can add some other more dramatic and dynamic eye movements to the repertoire.
Yeah, I mean, we can have different movements because this is capable of moving up and down as well as left to right. but maybe we'll learn something in trying to copy the Furbies movement, so that when we come to use those other movements in our mechanism, we won't overdo it.
Yeah. I mean, we don't want the Furby doing this, for instance, do we? It's very un-Furby-like.
So the next thing to do is to try to replicate those two movements on the car and the dart.
Okay, yeah.
And you're going to try and do that in code, aren't you?
I'm going to try with my very rusty Arduino skills to see what I can do, yeah.
So you managed to get the values from the potentiometers displayed on the screen.
That's right. We're using something called PuTTY. It's a serial monitor, and those values are being displayed on the screen now. They are being output from the Arduino as it steps through the different values that represent the animation.
So you made this table and we filled in the values for each movement.
So this was when we were replicating this particular Furby animation using the joystick and a potentiometer for the eyelids. So we were using a joystick to control the eyeballs and a potentiometer to control the eyelids, and we were replicating the Furby movement, and for each step we noted down the values.
So for the car, it looks straight ahead first, and then the eyeballs move to the right a little, and then you move to the right again, and then they go back to the default position. And when it says dar, the eyeballs are looking straight ahead, but the eyelids open wide. So we noted down the position on the potentiometer of the eyelids and the eyeballs, the X valve moving left to right.
Yeah.
And then you put that into a program, and this is the result. So it moves to the right in two positions, opens the eyelids, and then closes them again, going back to the default position. But we found that the routine that you've got with because you put delays in, didn't you?
Between each movement, I've just put a random delay in just so that we could check everything was working first. But I think the random delay I used was 1 second between each step movement, and we found that when we played that back with the Furby sound, it didn't correspond. They weren't synchronized as they were on the original Furby.
On the original Furby, the phrase takes 4 seconds altogether. Each word takes a second.
Seems to take a second, yeah.
But this sequence that you programmed takes 8 seconds, so it's twice as long.
Yeah, so I need to adjust the delay values so that it's in sequence with the car, dar, nu, lu.
Yes,
yeah.
So that's what you'll be doing next. You'll be working on reducing those delays.
Yeah.
So that it's of the right duration for the phrase.
That's right, yeah. It's been an interesting process. It's been a lot more involved than we thought it would be to capture these original Furby movements by watching the eyes and the sound, listening to the sound, and then trying to recreate them. But it seems as though we're on a reasonable track to try and duplicate a lot of Furby eye animations synchronized with the Furby sounds.
So you've altered the program now, and we tried to make it as close to the timing of the Furby eyes as we possibly could.
That's right. I think we've got 420 milliseconds between each movement now.
So we'll just show you what that looks like now. So we were concentrating on getting the dart in sync with it opening its eyes wide, and I think we achieved that.
Yeah.
What else do you want to say about this, Paul?
The way we go in about trying to capture the Furby eye movements and duplicate them is only going to be an approximation. For a couple of reasons I can think of. the step size between movements that we're using. At the moment we've got it to 420 milliseconds is not necessarily the same on the Furby between each of its eye movements. Also, when our eyes or eyelids do make a movement, they're just moving at the full speed of the servo, whatever the voltage is set at, and we're making no attempt to control that programmatically. But after having said that, I like to try and keep it simple, and you do, especially programmatically, because neither of us is a brilliant programmer, and I think what we're doing is capturing it pretty well.
I suppose also when I create the Furby voice, I can sort of speak it closer to how it's moving when we finally have the animation as well, to get it more in sync.
Yeah, you could do that, but I think we'll have to accept that our version of the Furby...
Well, yeah, it's not going to be identical.
Yeah.
But you just want a flavour.
We do, yeah. We just didn't want it to get too far away from what a Furby does.
Yes. So you've got the program loop here, Paul.
Yep, the program loop we've got is very small. Everything else has been made into a function. So, yeah, we've got 3 arrays for the left and right movement of the eye, the up and down movement of the eye, and the movement of the eyelids. And then below it, we've got a for loop. So that's got 7 steps in this particular eye sequence, and it just loops through the for statement 7 times, using the values out of the arrays to move the eyes and the eyelids.
So, is this Will Cogley's code, or are these lines of code that you've added?
Right, these are lines of code that I've added. They're just simple lines, but it is calling Will Cogley's code as functions. All Will Cogley's code is outside of the main loop, as I call as functions.
Right. So I think the next logical step would be to try to get some sort of app or software that alters your voice, so that I can try to do this sentence in a Furby voice.
So that sentence is Car da Nulu. Yeah.
I think that's the next logical step.
Yeah, we can try that.
And then maybe after that, we might want to try and make some new eyes.
Yes, and we'll be back to Will Cogley's site, Nil High
Mechatronics,
because he's done some wonderful eyes. But those are human eyes, and we'll want to try and do a Furby variant, but based on Will Cogley's technique.
Yes, much bigger pupils than a human eye.
That's right, and they've got like a faint purple band around the perimeter of the pupil, I think.
So, I hope you found this video interesting, folks, and I hope you'll join us in the next part. But that's it for this video. Thanks for watching as always, and hope to see you next time.